Callahan, I need your John Hancock on these reports. John Hancock.
Okay, so let's take a look here at prereq 7, the last prereq session before we start right into trig in algebra 3. This is on rational expressions, something else that you should hopefully know. So let's see what you guys should know. Simplifying rational expressions. Okay, so something like this is why we spend all the time factoring. If you want to simplify a problem like this, you can't just say, oh, here's an x squared and here's an x squared and cross them out. There's a 2 and a 4, we can divide them. No, it doesn't work that way. The only way you can cross out things in fractions is if it's dealing with multiplication in things that are in parentheses. So we need to write it that way. What that means, we need to factor both the top and the bottom. So I'm going to start by factoring the top. So that's slide and divide. 3 times a negative 2 is negative 6. So it multiplies to give you negative 6 that adds to give you a negative 5. Well, the first thing that comes to my attention is the negative 6 and the positive 1. So we have this. I'm going to do factoring by grouping for you, just so you can see it with factoring by grouping first. I'm going to divide by 3 on both these to pull the 3 out. And I'm going to take an x out of both, because they at least have one x, leaving me with an x and a minus 2. We already have a 1x minus 2. But remember, I told you when you're factoring by grouping, make sure, even though you're factoring by grouping, you need to make sure that you at least pull something out. So since it already is what we want, we're going to pull out a positive 1 and have an x minus 2 there. So when I combine those together, I get a 3x plus 1 and an x minus 2. That's what the top is. So I factor the top, and that's what the top is. I need to factor the bottom now. Well, this happens to be a difference of squares, which is what we talked about in the last section. This x is x squared, but can I rewrite 4 as something squared? Yes, that happens to be 2 squared. So I can rewrite this as an x minus 2, right, and an x plus 2. So I can rewrite those. So when I rewrite these as x minus 2 and x plus 2, now I need to rewrite this whole problem. So what that means is this, we just said, was the top. This is the bottom. Now we can cross things out. Now we can cross things out to simplify. Now that the top is factored and the bottom is factored, we can cross items out. And the items that are the same, the x minus 2's, right? Since they're both the same on the top and the bottom, we can cross both of those out, leaving us with a 3x plus 1 and an x plus 2 as our final answer.
Hey, does this suit make me look fat? No.
So with this example, I need to factor again. But in order to do this, you're not used to seeing something like this, so we're going to rewrite that top. We're going to put it in order, in standard form. So that means it's actually negative 3x squared minus x plus 2, and the bottom is 6x squared minus x minus 2. So we're going to factor both the top and the bottom. So to factor the top, I'm going to slide that negative 3 and multiply it by 2 to get a negative 6. And we have a negative 1. So what multiplies to give you a negative 6, that also adds to give you a negative 1? Well, that happens to be a negative 3 and a positive 2. So all I'm doing is rewriting the top as negative 3x squared, and I separate this negative x into negative 3x plus 2. This was that factoring by grouping method that we first talked about. If you want to do slide and divide, you can. I think slide and divide is easier, but I'm trying to show everyone every different type of method to do this. So factor this by grouping, and when you do this, I'm going to take a negative 3 out of both, and I'm going to take an x out of both. So when I do that, I take a negative 3x out, leaving me with an x plus 1, because negative 3 divided by negative 3 is a positive 1 left over on the inside. Over here, they both have a 2 in common, so I'm going to take a 2 out of both of those, leaving me with an x plus 1 as well. So when I combine them together, I get a negative 3x plus 2. And then, since those are the same, I get an x plus 1 combined at the end. So there is the top factored. Now I need to factor the bottom. So to factor the bottom, I slide 6 times the negative 2 to get negative 12. So what multiplies to give you negative 12, that also adds to give you negative 1. Well, negative 4 and positive 3, which means I can rewrite this, right? I can rewrite the negative x here as negative 4x plus 3x. So I group these two items together, right? I can take out a 2 in both of those, and I can also take an x out of both of those. So when I do that, I take a 2x out. 6 divided by 2, I have a 3x left over, and negative 4 divided by 2 is a negative 2. Once again, like before, I have a 3x minus 2 already in here. So what do I take out when there's nothing I can take out? I take out a positive 1. So I take out that positive 1, and I still have the 3x minus 2 there. So I combine them together, 2x and a 1 to get 2x plus 1, and that comes along for the ride. I got a 3x minus 2. So I have the top and I have the bottom factors. So when we're doing this, this is what we have. I have the top and I have the bottom. So now that I have the top and the bottom, and I have those factors, I need to see what cancels out. Well, here's the problem. Nothing cancels out right now. But when you're looking at this stuff and you're staring at it, you're saying to yourself, these two look kind of close together, don't they? They're really close. Well, what could I do to make those two actually identical? Well, what I can do is I can take a negative sign out of this. If I take a negative out, that becomes a positive, and a negative out of that, that becomes a negative. The reason why I did that is now I have a 3x minus 2 on the top and the bottom that cancels out. So I have a negative on the outside, and I have an x plus 1 left over on the top and a 2x plus 1 left over on the bottom.
Lucky.
Alright, so now trying to factor the top and the bottom on this one, we have to factor everything. So to factor the top, this one should be a little simpler. What multiplies to give you 16 that adds to give you 8? Well, 4 and 4, right? Because 4 times 4 is 16 and 4 plus 4 is 8. So this, because it's just a 1 out in front, I can just simply write as x plus 4 and x plus 4, and that x minus 5 comes along for the ride. Underneath, I need to factor this item. Well, what does this have in common that I can take out of both? So to factor the bottom here, I'm first going to look at this, and it actually has an x. I can take an x out of both those. So I end up getting x times x minus 5. Over here, if you look, I actually have the difference of squares, right? Because it's a subtraction sign. How can you rewrite 16 as something squared? You can rewrite that as 4. So I get an x squared and I get a 4 squared. So with that in mind, that actually becomes x minus 4 and x plus 4. And I have the x minus 5 and I have the x. So this is my whole bottom. And this is my whole top. So this is what we're looking at with them together. There's a whole bunch of stuff that crosses out now, right? I have an x plus 4 and an x plus 4. They'll cross right out. An x minus 5 and an x minus 5. They'll cross out. But a plus 4 and a minus 4 don't cross out. And I still have that x. So what I'm left with is an x plus 4 and on the bottom an x times x minus 4 as my answer.
Who are you? We are the knights who say...
Alright, so when I come back here, we will try to finish up on Prereq 7 on simplifying some rational expressions.